All right, here we go. Okay, so we're going to use absolutely, positively everything that you've learned in this chapter so far, all in this section. So some of you are going to be a little stressed because you're going to go, how do you know to do that? How am I going to know to do that? The more of these that you do, that's all I can say, the better you get at them, okay? So here we go. All right, so the first one says, first of all, remember the difference between exponential form versus log form, right? And that the common base for a log is 10 and the common base for a natural log is 5, right? This is an interesting one. Look up here. I don't actually think, I was staring at it because I don't actually think you're using this in this section. Let me know if it comes up. So notice that the base here, this is an equation, it's got an equal sign. The base here is 10 and it has an exponent with a log in it, right? So the answer though is 5, right? Isn't 10 the natural log base? Right? And then over here you've got e raised to the natural log. Did I say the natural log? The natural base, the common base over here. E is your natural log raised to the natural log of 6, right? Isn't that the common base for the natural log? Mm-hmm. Out of 6, and the answer is 6. Fascinating, don't you think? Well, it might be useful. That's something kind of new, isn't it? All right, so then let's look at example 1. Exponential equations, that means if x is in the exponent. So we've got a is equal to 2 to the x is equal to 32. We've had this before, right? I have a base of 2. My exponent is, my variable is in the exponent. Can I convert 32 to a base of 2? Yes. Yes. So 2 to the x is equal to 2 to the what? 2 to the 5th is 32, isn't it? Now that I have the same bases, aren't the exponents the same? So that one was nothing new, right? They're going to combine the old with the new. So this one you could actually do 2 different ways. You could either make 9 into a base of 3 and put it as a fraction 1/3, right? Or how can we change 1/3 so it's a base of 3? 3 to the negative 1, right? Raised to the x equals 9 is 3 to the what? Squared. And then power to power, don't we multiply? So I have negative x is equal to 2 because now my bases are the same. So what does x equal? Negative 2. Otherwise, you would have had to convert, if you left it this way, you would have converted this to 1/3 to the negative 2, wouldn't you? 1/3 to the negative 2, isn't that still 9? Yeah, so 1/3 to the negative 2, wouldn't x be negative 2? Still negative 2, so that works as well. All right, look at C. This is different. What's your base this time? E. What is the common base for the natural log? E, right? Okay, so what I do, this is an equation. Whatever I do to one side, I do to the other. And remember, if I can make this the same, what happens here on this side? What is this side's value? X. I get x out of the exponent, right? Whatever I do to one side, though, I have to do to the other side. So I'm going to take the natural log of both sides. When I do that, the left side here becomes x because of this, and the right side becomes the natural log of 72. So x is equal to, now you can use your calculator. So grab your calculator. Yeah. All right, come on up and get the other one. Switch with you. All right, so I'm going to find the natural log of, what was it? 72. Let's round to, I don't know, 3 decimal places. So what does that round to 3 decimal places?
4.277.
Yeah, because there's a 6 next door, the 6, bless you, the 6 rounds to a 7, so 4.277. And I went to squiggly equal signs because I estimated, right? So it's approximation. So notice that this one was different than the other two, right? The first two we've done before. Now this one is a new method of solving, right? There is no way that I could have changed 72 to a base of e. Isn't that correct? If you can't change both sides of the equation to the same base, then take the log or the natural log of both sides. I only took the natural log because e was involved. If e is not involved, then you take the regular log. Okay, so look at this one. For this one, we got this, what's different about this equation? There's a 3 outside, isn't there? If I were you, I would take care of that 3 first, because otherwise it's going to make it a real pain. So divide both sides by 3. You get 2 to the x is equal to 14, right? Can I change 14 to a base of 2 like we did in letter A? No. Is e involved? No. But I can still take the log of both sides. Now, if I take the log base 10 of this side, that's not going to help me, is it? I need to take the log base 2. You can take the log of whatever base you want to. I'm going to take the log of base 2. Won't that make this whole left side become x? So then I have to take the log base 2 of the right side. So I end up with x equaling log base 2 of 14. Please make sure that this is a subscript and that is on the same level as the log. That's one of the things I've noticed on your last quiz, that you're making the 14 look like an exponent, and we really have an exponent of 1 here, don't we? Right? So now can't you do that, change a base formula in your calculator? X is approximately equal to the log of 14 over the log of 2, or those of you with the fancy dancy calculator can go to the math feature of your calculator, right? And go to alpha A and hit log base 2 and 14. Either way, you should still come out with, go out to 3 decimal places. What do we have? 3.807. Isn't that fun? I love this stuff. It's great. All right, so tell me what you've learned on E. What have you learned to do for E? Divide by 4. Right? Now 4 doesn't go into 5, but that's okay. Don't let that bother you. So I have e to the 2x is equal to 5 over 4. Because e is involved, take your natural log, right? It's not pretty, but we're still going to take the natural log of both sides. And because this base is e, my left side this time is 2x, not x, right? My right side is natural log of 5/4. How do you solve for x? Yep, so we're going to divide both sides by 2. So what you're going to put in the calculator is, you're going to put this in first, hit enter. Make sure you close your parentheses. Get in that habit right now, whether you need to or not. And then divide your answer by 2. So, natural log of 5 divided by 4, close parentheses. That's the natural log of 5/4, and then divide that by 2. 3 decimal places, what are you going to round it to? 112. So 0.112. A calculator is a beautiful thing, right? How do you feel about that, Mr. McGraw? That's not so bad, is it?
No, it's not bad.
But he's waiting for the other shoe to drop. Okay, so then let's look at example 2. And the other shoe's about to drop. Are you ready? Now, what does that look like to you? the directions say this is in quadratic form. What's a quadratic mean?
X squared plus bx plus c.
Ax squared plus bx plus c, right? It's the graph of a parabola, isn't it? Okay. Its highest degree term is 2. So, but we have e's involved here, don't we? Well, remember at the very beginning of this year, we had to factor, oh, what was it? Was it like 2v, all of that raised to the second or something like that? You remember that? It was kind of crazy trying to factor something that was 2v, all of that raised to the second, minus 3 times 2v plus 6 equals 0. Remember that? Sort of? Do you remember that? Okay, you're not remembering that. Well, here's what we're going to do. We are going to let y equal, look at this right here. This is really not to the second power. How could I rewrite that so that it's something to the second power? Take this exponent, divide it by 2. Because remember, power to powers, we multiply. What's this exponent divided by 2? X, right? So what is e to the x squared? Power to power, what do? Doesn't this become e to the 2x? Do you see the quadratic in here? So it's this squared. What's this? E to the x. So we're going to let y equal e to the x. I'm using y because I don't want to use x and confuse e to the x, that x with x. So if I let y equal e to the x, this is what I have. Can't I replace each e to the x with a y? So it looks prettier. Whoops. I'd make a terrible doctor. Whoops. Or a dentist. Whoops. Sorry. Oops, I made my quota of mistakes for the day. Now, doesn't this look like something you could factor? I'd rather factor this than this, wouldn't you? How do you factor this? Yeah, what factors of 2 add to give you negative 3? What factors of 2 add to give you negative 3? What might they be? 1 and 2 add to give you 3. We want our 3 negative. So the 2 is negative. What's the 1? Negative. Since there's no coefficient in front of our squared term, can't we just throw those in parentheses? So the y squared becomes y and y, because I said so. And then the minus 1 and minus 2 go in there. That's your math joke for the day. That's a little late. All right, so then I want to solve each one of these, correct? So set these equal to 0. None of that's new. What does y equal? 1 and y equals 2. But is that really our solution now? No. So what are we going to switch y with? E to the x. So now we have to replace y with e to the x. So e to the x equals 1 and e to the x equals 2. How do we solve that? And this is the reason why you learned what you did above. Because e is involved, take the natural log of both sides, right? And remember, this has a base of e, so my left side is x. Without your calculator, what is the natural log of 1? If x is 1, think of your natural log graph. If x is 1, what is y? It's a critical value, right? So without your calculator, I know that the natural log of 1 is 0. So that's one of our answers. And then take your calculator and find the natural log of 2. Or actually, this will be a squiggly equals.
Does it really matter if it's equals?
Yeah.
Did you come off like that?
No. But if you're a NASA engineer, the squiggly equals would make a big difference of getting to Mars or not. It might. At some point, they become very necessary. I'm jumping up for joy if you know that this is the answer. Woo, yippee. All right, so round to 3 places. What do you get? 0.693.
Yeah, well, the test has to do a good enough job.
Enough has to do a better job than government work, because then they're not going to get where they need to be. No, they didn't get shut down. A president shut down their program. Yes. He shut down their program. Good thing I'm not an astronaut. I'd be very sad about now. Actually, they have other jobs. They've been pushed elsewhere. Enough about astronauts. So, there's your answer. X has two values. Because this is a quadratic, it makes sense. It has two values. This is where this quadratic would cross where? The x-axis. Okay? All right, so flip. You thought you were done. Now your second shoe's dropping. Now we're going to solve log and natural log equations again. But you know how to do this one, right? How does this one work? Yeah, add the e, and then what do? Change it to exponential form, right? It's currently in log form. How do you change that to exponential form? Same base, e to the, you switch these two, don't you? E to the 2 is equal to our x. So go to your calculator and find e to the 2. E again is above your division symbol, and then square it. Round to 3 places, what do you get? 389, yep. So x is approximately equal to 7.389. That wasn't so painful, right? Look at B. Go to B. Now that's a little different, right? Now use your algebra skills. If we can get this part right here by itself, can't we do what we just did in A? Let's get it by itself. What do you do first? Subtract your 5. So we've got 2 natural log of x is equal to -1. Right? Not subtract 2, but divide by 2. So the natural log of x is equal to -1/2. Now what do you do? Yeah, put your e in there, right? Put it in exponential form, e to the, switch these two, e to the -1/2 is equal to x. So x is approximately equal to, we're going to use our handy dandy calculator. You might love your calculator, but guess what? It just makes the problems more difficult. Now we can give you harder problems.
Once again.
E to the -1 divided by 2. Make sure you're using your negative sign and not your subtraction sign. And 3 decimal places gives you? Yep. So approximately 0.607. Did you use the subtraction sign instead of your negative? I'll bet you did. Is it? Yeah. It's easy to do. All right, look at C. Ooh, gracious. Now, what else did we learn that could help us get the natural log into one log? Because if I can get the natural log on the left and the natural log on the right, if I can get just one natural log here and one natural log there, if they're all of a base of e, isn't what we're taking the natural log equal to each other? How do you get this to become one log? Because of the addition, we're going to multiply it together. So we get natural log of x minus 2 times 2x minus 3 equals 2 natural log of x. What else? What do you think I have to do first? I need to swing that exponent back up here, right? So I've got the natural log of x minus 2 times 2x minus 3 equals natural log of x squared. Now I have this natural logs here. These parts right here should be exactly the same if those are equal to each other. Agreed? So can't I drop the natural log part? I can. So now I've got x minus 2 times 2x minus 3 equals x squared. Now what do you do? FOIL, double distribute, right? X times 2x, 2x squared, x times negative 3, negative 2 times 2x, plus 6 equals x squared.
Did you distribute like before that?
I'd rather you didn't. Well, I mean, you could. You mean still leaving the natural log there? Yeah, you could have. Yep. I like to wait though in case I see what's on the other side, so I don't do extra work if I don't have to. So, what do I have to do before I can solve? Yep, we have to subtract the x squared. We have to have one side equal to 0. Which is nice because I end up with an x squared, which is much easier to factor, right? Minus 7x plus 6 equals 0. That ought to factor into two binomials. What factors of 6 add to give you 7? Yep, they both have to be negative to make that a positive and that a negative, and then x and x. So what does x equal here? 6 and here? Positive 6 and positive 1. Thank you. Now, I need you to go back to the original equation and you need to plug them in up here. So if x is 6, what's 6 minus 2? 4. Can I take the natural log of 4? Is that in the domain? Remember, your domain is restricted to taking the natural logs and the regular logs of what? Positive numbers, right? Not 0, not negative numbers. So that one works, doesn't it? Does it work over here? What's 6 times 2? 12 minus 3? 9. That works. And then natural log of 6. That works. But look what happens when I put 1 in. What's 1 minus 2? We have an extraneous solution. We have to throw that one out. That means that this is our only solution. So I want you to add yourself a little note here to the side because you're going to forget. So right there, I'm going to move this up so that you can see my note. Right there, doesn't check. It creates a number outside of the domain. In other words, it makes the natural log a negative, and you can't take the natural log of a negative number. So you do have to constantly go back and check. So that's why some of you might have 2 answers today, and there's only 1 answer in the book. All right, so now look at D. I have to compress, right? This time I'm just regular log, so I've got log base 4. You can't drop that off. If I'm going to put the x in front, times x minus 6 is equal to 2. I only have 1 log, right? What do I do with that? 1 log, you change it to what? One log, you change it to what? Exponential form. 2 logs, I try to get the same logs into 1 log on both sides, 1 log on each side. So because I have just 1 log, I'm going to change that into exponential form. So my base is 4, switch these. So 4 squared is equal to x times x minus 6. You okay with that? Does that make sense why? Yes or no? No? I have 1 log, right? Don't let it bother you that that's complicated. What if I had this? Wouldn't you change it to 4 squared equals x? So don't let the fact that this is more complicated bother you. I still have 4 squared, but it's equal to x times x minus 6. So now distribute your x and square your 4. 16 equals x squared minus 6x. That's a quadratic, isn't it? Subtract your 16. I get 0 equals x squared minus 6x minus 16. So what factors of 16 subtract to give you 6? 8 and 2. So if I have an 8 and I have a 2, for my 16 to be negative when they multiply, one of these has to be negative. Which one is it? The 8 has to be negative because it's the bigger one. The 2 is positive. So that gives me an x of what here? 8 and negative 2. It might be okay to have a negative. We just have to check it in the original. So what is 8 minus 6? That's okay, and the 8's okay there. What about the negative 2? What's a negative 2 minus 6? Can we have that? All right, so we're not canceling it because it's negative. We're canceling it because it creates a negative log, right? And so that means that's my only answer. All right, last one. This one says solve using the calculator. But before I can do that, I can't just plug in natural log of 4x equals 1. Your calculator's not going to do that. I have one log. What do you do? Yeah, this has a base of e. I have one log. I want to put it into exponential form. So my base is e. Switch these two, just like we've done. So it's e to the first equals 4x. We are solving for x. How do you solve for x? Divide by 4. So x is equal to approximately. Now you get to use your handy dandy calculator. So e raised to, oh, no, sorry, e divided by 4. So round to 3 places, what do you get? Yeah, because the 5's here and the 9's here, the 79 rounds out to an 80. So you get 0.680. So that's a lot to take in, but it combines everything that we learned. You really didn't learn much new today, right? You just used it in harder application problems. Joey? Friday. Yes, over 3-3 and 3-4. So we're going to review Wednesday and Thursday, and you'll take it on Friday. Yes. Yes.